Welcome to PASS Virtual Summit 2020. This is SQL Server Security Principles 101. My name is William Assaf. I'm a senior content developer at Microsoft. Please explore everything PASS has to offer, including this summit, but also the free and pro memberships, local user groups and SQL Saturday events near you, occasional PASS marathons on various topics, virtual user groups, which happen all the time, all over the world, and then please get involved in volunteering for your local PASS community wherever and however you can. Your feedback is important to us. Visit the session evaluation link in the left-hand side navigation bar to rate this session. A little bit on me. I spent the last 13 years as a consultant and most recently a principal consultant and leader of a SQL Server consulting team. Just for the low price of attending this session, I've included a toolbox of SQL Server scripts to accompany this presentation. It's available for download on the PASS Summit website accompanying this presentation. So this is a common grammar issue in the English language, the difference between principal PAL and principal PLE. Both can be a noun, but PAL describes a person who can be your pal. Principal PLE is an inanimate thing, like a guiding principle or being principled. So today, we're really talking about both. Principals, PAL, are not only what SQL Server calls security objects in the database. Principals, PLE, that guide how we as DBAs should design and create securables in our servers and databases. My title at my last consulting company was Principal Consultant. So this principal is going to share with you his security principles so that we can all be principled principals who follow principles of security. So I want to start out with some really basic terminology just to make sure we're all speaking the same language here. A user has a database context. It is often linked to a login. Not all the time. We're going to talk about that. And it does not have a password most of the time. We're going to talk about that too. It is stored in a database, and user databases have users in them. These are included in the database restores. If you restore a database backup from one instance to another, the users come over. And the user is given access to things in data tables like select, update, execute, create table, etc. A login exists at the server level. It connects and authenticates the SQL instance. It's either linked to Active Directory or Windows authentication, or it has a password in the instance, and this is in the case of SQL authentication. We're going to talk a lot about the differences between those two. It is stored in the master database. So it's not stored in any other databases. Logins are only stored in the master database, and it's given access to connect, view server state, create database, server level things. Same data here. We're looking at the Object Explorer in Management Studio, and you'll notice there's two folders called security. One in the database level under the database W, and another at the server level. And the server level security has a subfolder called logins. The database level security folder has a subfolder called users. You see here I've circled a login and a user of the same name in both cases. Now, what we're going to talk about is that the name of the login and user does not tie them together. It's actually under the covers a SID, a security identifier that links the user to its login in each database. And more importantly, let's talk about something that I've done here that I shouldn't have done, because we should not grant logins to individuals, even individuals' administrative accounts. We should grant logins to roles, to security groups, ideally. So you should create logins to AD security groups. You need to insist on this as the DBA, but you should also be aware of what or who is a member of those groups and what groups are member of those groups and so forth and so on. So you can figure out what members of security groups there are from within inside SQL with this XP login info, but that does not return recursive results. It only returns the first level members. So instead, to vet what is a member of an AD security group, I recommend using PowerShell instead, the get AD group member commandlet. Both the server logins and the database users have roles. These are built-in roles. You could also create your own roles at the server and the user database level. Roles are security principles themselves. They can be assigned permissions. Logins are added to server roles. Users are added to database roles. Built-in roles provide a standard for access, but this standard for access may be too broad. For example, inside the database, the DB data reader and DB data writer, which you're likely familiar with, these allow for read or write to the entire database. This is not likely to be the case in all databases. Also, you should follow the principles of role-based authentication, and you should grant roles and groups membership to these built-in roles. So role-based authentication, or RBAC, is an acronym that many in the governance area are familiar with. The idea that nobody gets their own permissions that are unique to them. They're only granted permissions based on their role, not their individual needs. Role-based access control means that creating specific permissions is a meaningful exercise because it's applied to members of a group. While you can add a role to the built-in database roles like DB data reader, DB data writer, it might be overreach. Your data within a database may not be homogeneous in terms of its sensitivity or permission to access. Later, we'll talk about schemas. Those are also security principles, a great way to grant more specific permissions than to all the objects in a database. Last, on the sample images here, you'll notice that the public roles at both the server and database level, the public role is checked, and it can't be unchecked. Let's talk about public. So every login is a member of the public server role. Every user in each database is a member of the database's public database role. Only short-sighted developers would grant permissions to public, which allows every user that does now or ever will exist to inherit permissions from public. Permissions assigned to the public role is a clear sign that someone isn't thinking this all the way through. Don't be lazy. Don't assign any permissions to public, because this would fail any application security or database security audit. You can expect some non-issue findings from the database diagram feature that's built into Management Studio, where they granted access to public. Not exactly a security flaw, it's just the database diagram, but you could see how other third-party vendors granting access to public could be a problem. It's a real pain to unravel because it involves lots of testing and almost certainly requires participation from the developers to figure out what permissions were actually needed for what roles, grant those permissions, and then revoke the permissions from the public role. There's actually a toolbox checklist script here for you. The first thing I'm going to mention in the toolbox, called public permissions. Use this to go and vet and see what permissions in your server or database levels are granted to public, and go fix them before any kind of security audit. Similarly, the guest role is a special built-in user in each database. Any login that doesn't have a mapped user in a database inherits permissions from guest. If that sounds like a bad idea, it is. It's a terrible idea. And by default, this is disabled in all databases. You should check for this, and there's a script to do this here. So for what should be very obvious reasons, never grant any permissions, even connect to guest, unless you really understand what you're doing in some sort of multi-tenant environment. If a login doesn't have a user in the database, it shouldn't have access to that database. So guest is not a secure solution for future access. Similarly, the guest permissions or even enabling guests should trip any SQL Server security audit failure. Okay, logins are given a default database. And when you connect, it will try to set the initial database context to that default database, and that connect will fail if the default database is no longer accessible. So, as a best practice, set the default database to the intended user database if, for example, you have a user that's always going to be connected to one database. That way, if that database goes away because of a migration or an outage, the login is effectively disabled as well. Or you can grant the default database on sysadmin roles to the temp DB, which is always there, so it won't ever block authentication, but it's not persistent. And this solves the problem of people accidentally creating objects in the master database when they connect, because master is the default. Let's talk about logins and how they connect to users. So a server login is what authenticates a connection to SQL most of the time. A database user provides a login with database access. So let's talk about the different types of SQL Server logins and how they're differentiated by how they're authenticated to SQL Server. SQL Server authenticated logins, we'll talk more about this, but this means that each SQL Server is now an authority for its own credentials. If you have 10 SQL Server instances, That's 10 different sets of logins and passwords to maintain, as opposed to one set in Active Directory. The Enforce Password Policy checkbox is encouraged, but it's definitely not required. Strongly encouraged to enforce the password policy, which includes things like password expiration, inheriting from the same settings as in Windows. Unfortunately, the password policy in SQL Server is entirely optional. In Azure SQL Database, it's actually enforced all the time, which is a great security feature. But in SQL Server, the password could be password or empty string or the same as the username if this box isn't checked. Also, if a login doesn't currently have the password policy enforced, you can go ahead and check that box, but it doesn't apply to the current password. So it's way too easy to mark a login to apply policy, but have that password that is not strong enough to meet that policy, because the policy would then only be checked if the password is changed. So really be careful about enabling this checkbox if it's not checked on an existing login. Finally, multiple failed SQL authenticated login attempts will lock out the login, which requires a DBA to resolve. Because these credentials are specific to each instance, it also means that SQL logins must be synchronized, more or less manually, between replicas in an availability group. And so finally, see here, a plain and clear screenshot from Microsoft Docs. Use Windows authentication as possible, when possible. Let's talk more about that optional password policy in SQL Server for logins that are SQL authenticated. If you're a sysadmin, you can perform what is essentially a rainbow attack against your own SQL Server to look for weak or easily predicted passwords. You can do this because SQL Server makes the one-way password hash function available to you. So you can run any string through the same hashing function, then compare that one-way hash to what SQL Server stores for the password. So while you can't reverse engineer or decrypt a password for a SQL authenticated login, you can generate a hash of any string and then compare the hashes. And you can do all of this without failing a login attempt or locking out a login. So there's a script here in the toolbox called Easy Passwords that you can use. Fill in some password guesses of your own, like based on your local sports environment or the name of your company. It will also add some guesses based on the other names of logins and databases in your domain, and then do some character substitutions to try to guess easily predicted passwords. You should go and then change those passwords. So we've talked about how SQL authentication really creates additional administrative overhead. In comparison to Windows authentication, specifically using Active Directory, SQL authentication creates a decentralized security setup in each instance. In a typical enterprise business environment, Windows authentication means that account creation and termination, security group membership, and password policy are all handled by an existing corporate security administration infrastructure. The same infrastructure that creates logins for new users and deactivates logins for employees who've left the company. Centralizing that account and password management in Active Directory, along with role assignment for security groups, well, these are all good things to do from a governance standpoint. And from the standpoint of, you know that thing you see on certification exams all the time? Least amount of administrative effort? Proper use of Windows authentication model creates server logins that are linked to domain accounts, preferably linked to security groups in Active Directory, not individuals again, so that membership is also managed by your existing security infrastructure, not at each SQL server. Okay, back to talking about logins and users. A user can be linked to any server login. The names don't actually have to match, but they should, unless you're crazy. A security identifier, this behind-the-scenes number, is what's actually shared by the user in the login. And so you can see here, I actually have a login and a database user in a database that have the same SID. They also have the same name, but they have the same SID. In Windows authentication, as you can see right here, that SID comes from the Windows provider, likely Active Directory. So in all SQL servers where that domain account is used, it's got the same SID. Now, here's the login mapping for the database user. You can see here logins are mapped to users in the user mapping page of the login properties dialog. It's here that the mapping that users take on the SID of the login. Note here, there's also the special user DBO. We'll talk about this a little bit later on. This is a special user in each database that sysadmins essentially are mapped into. We'll talk more about DBO and its shifting definitions over the years later on. So we've talked about how logins and users are mapped by their SIDs. So what happens when this link is broken? Database users can become disconnected from their SQL authenticated login. This commonly occurs when a database is restored from one SQL instance to another. And this only breaks with SQL authenticated logins, not Windows authenticated logins. Now, why is that? Why would this only affect SQL authenticated logins? It's because unless you specify a SID yourself, the SID for a SQL Server login is generally local at each SQL Server instance. If you go and create a login named test on 5 different SQL Server instances, you'll get a login named test with 5 different SIDs. There's a way to create a SQL authenticated login with a predetermined SID that you provide in T-SQL. This is how migrations happen. We'll talk about that next. If you create a Windows login for the same Active Directory account on 5 instances, each login has the same SID because all 5 SQL instances got the SID from the same place, Active Directory. Therefore, any user associated with the login will have the same SID on any SQL instance. That's why a Windows authenticated login can't become orphaned from its users. This becomes incredibly important for availability groups, where it's much simpler to distribute a Windows login from AD to each replica versus distributing a SQL authenticated login to each replica, scripting it out to use the same SID in each instance. Let's say that the login already exists, and we need to go ahead and repair the user, link it back with its login on the new instance. This command is actually really quite simple. You can also proactively identify orphaned logins by comparing their names and SID in the SQL Server's internal metadata. Here's the basic join. There's a script in this session's toolbox, again, that helps you quickly identify and repair orphaned SIDs. If you're an experienced DBA, remembering to look for and fix orphaned SIDs is a necessary follow-up anytime a database is restored from one server to another. For example, to update a dev or test environment from production. As you can see, the join looks for where the name matches, but the SID does not. So you'll know you have a problem with an orphan SID if the end user or application gets an error like this, especially after you do a database restore. The server principal is not able to access the database under the current security context. This is a symptom of a mismatched SID, or the user's just not there. And so here we can verify that in the system views, indeed, I've got a SQL authenticated login and a database user of the same name, but different SIDs. And after running alter user with login, you can now see that the database user has been modified to reflect the SID of the login on this SQL instance. So it's the user that gets its SID changed to match the login. So like we said earlier, it's not possible to reverse engineer a SQL auth login's password, but you can guess it an infinite number of times via the hashing algorithm we discussed earlier, but you still can't see it. So when migrating SQL logins to create it from one server to another during an important upgrade or migration, you have options. The first is to do a backup and restore of the master database, which is obviously only possible in a migration to the exact same SQL version. You may find this more or less impossible if the drive letters are changing or other server conditions are changing as well. So consider restoring the master database an important disaster recovery option in the event of a bare metal restore, for example, or a rebuild, but not an option for server upgrades or migrations. Scripting out a SQL login with the same SID but a new password is also possible. Maybe you want to do this intentionally to break connection strings for old applications, maybe. But unless you want to do that, it's unnecessary because we can create a hash of the password without knowing the password. And using that and the same SID from the original server, we can create a login on the new instance that will work. This is easily scriptable. Let's talk more about that. So Microsoft has provided us a pair of stored procedures to generate the hash of passwords, SP hexadecimal, SP help rev login. You create them both in the master database and then you execute SP help rev login. But don't forget to migrate the server level permissions too. There's a script in the toolbox here to help you with that. So again, we've been talking about the difference between logins and users and how the SID, not the name, connects them. Now, don't forget everything I just told you, but well, there's this thing called contained databases. It's not super common architecture, but it is notable. It moves authentication from the server level directly into the database level. A contained database owner, for example, has full control over security, but only inside the contained database. And there are no server level or sysadmin level permissions necessary to administer security in that database again. And the contained database has no configuration dependencies on the rest of the instance. It can be easily moved to another instance. So what this means is that this syntax, which heretofore made no sense, on a contained database is perfectly valid. Create user with password. So this is that asterisk on my earlier slides, talking about how only server logins have passwords and database users are linked to logins. Well, that's only most of the time. A contained database user is a database user with a password, or a database user directly tied to a Windows user or account that does not already exist as a login. That's the second example in the script here. Here in contained databases, the user is the contained portable method of authentication to the database. That's not how regular databases in SQL Server work, of course. So, a platform where all the necessities for authentication and system objects are stored in the user database. No system databases are needed, so the database is easily portable between server instances. What does this sound like to you? Azure SQL Database, of course. This is the whole purpose of a contained database. Unlimited portability on the back end, where Microsoft can move the database from instance to instance inside Azure without having any ties to the instance. And everything is contained inside the database, including the authentication. You don't know or care what SQL instance your Azure SQL Database lives on. It's a completely contained and portable database. Microsoft developed this whole containment feature for Azure, then brought the contained database feature to SQL Server, where it's actually labeled partially contained because of some minor details. Now, this isn't a presentation about Azure SQL Database specifically, but let's talk about how the authentication and security principles in Azure SQL Database are a little different. The only real caveat when you connect to an Azure SQL Database is that you can't use use. You must set the context at login for the database. So get used to specifying the database connection in whatever application you're connecting to. Or here in Management Studio, you have to go to that second tab for connection properties and select the database you actually want to select to. You'll also see these new additional authentication types since SQL Server Management Studio 2016 came around. The Active Directory dash options, the three at the bottom there, are used for Azure Active Directory only as a replacement for Windows authentication option for Azure SQL databases. You can, of course, use SQL authentication for an Azure SQL database. That's really our only option for an environment without an integrated Azure Active Directory. For all the same reasons as Windows authentication for SQL Server, using the Azure Active Directory authentication in Azure SQL Database is superior. So, Azure SQL Database servers are logical servers only. There's a master database, but you can only store certain objects and do certain things with it. It's not like the master database in a SQL Server instance. Azure SQL Logins in master can be shared across databases in this logical server. If you choose to create multiple Azure SQL databases in the same logical server, it might actually make sense to do that. And I say logical server because in Azure SQL Database, all the databases are contained. And behind the scenes, they may exist on different hardware. So it's only a logical server in a logical grouping. It's not indicating a physical representation. Initially, the SQL Authenticated Server Login account that you specified on creation, upon creating the Azure SQL Database, exists as a user with administrative rights to all the databases on the server, and it's the only one like that. you can create a second full administrator, this time using Azure Active Directory authentication too. Just like in SQL Server, it can be created for an Azure Active Directory individual account, or, like we recommend, a security group. In Azure SQL Database, you can have logins in the master database, but more commonly you'll have contained users in each database. Again, that authenticates straight to the database, bypassing this logical server, bypassing the master database. In active geo-replication or Azure SQL databases in auto failover groups, there's that complexity of needing to maintain the Azure SQL Database logins in each logical server. So just like you would need to create and maintain the logins on each SQL server in an availability group, but in Azure SQL, you can choose to bypass that whole master database thing and just use the contained database users. So you can use Azure Active Directory accounts only for Azure SQL contained database users, but not for the Azure SQL Server, the logical server logins. For example, you can create user for an Azure Active Directory account from external provider. This is new. This is different from SQL Server. And you must add an Azure AD admin, which can be an individual or a group, via the Azure portal first. Only Active Directory accounts then can create other Active Directory accounts in Azure SQL Database. And really, this is the only complication. It's one you might forget at first, but only in Azure SQL Database, you have to be logged in initially with this Azure Active Directory admin account that you create in the portal to create logins or contain users for other Azure Active Directory accounts. So otherwise, despite what we just talked about with Azure SQL Database, most permissions, objects, schema, and authentication operate the same way in Azure SQL Database, Azure SQL Managed Instance, Azure Synapse Analytics, formerly the SQL Data Warehouse product, SQL Server, and SQL Server on Linux. In this presentation, when we're talking about permissions, stored procedures, views, functions, it's probably going to be the same on every platform. Azure SQL Database and Synapse are going to have some security-specific differences. We're not going to go into those in detail right now, but they're well documented. So this is a security presentation. Enough about authentication. Let's talk about permissions inside the server and inside the database. Some basic permissions broken down here into three categories, some of which you're probably already familiar with. There's DML, the data manipulation language. This actually has to do with rows and columns in the database. DDL is data definition language. This is the structure of objects in the database. So you'd use alter on a table or a stored procedure or a view, for example. And then there's the keywords to modify security and the permissions associated with the ability to modify security. So we grant, we revoke grants, we revoke denies, and then we can impersonate. We're going to talk about that last one as well. So some common permissions for non-sysadmins. Of course, if you're a sysadmin, you don't need any additional permissions. So what do we do with developers and other folks who are not sysadmins but might need to do specific activities inside of our SQL Server? Alter trace would allow the developer to run SQL Profiler and traces, but traces are old news. Traces are deprecated. Let's not use those anymore. So if someone comes to you wanting to trace your SQL Server, talk to them about extended events instead. Your SQL Server will be much happier because extended events are for the most part asynchronous and they can get the same data out of it. So instead of alter trace, grant them alter any event session. Teach them how to use extended events, point them to the documentation, and have them use X events instead of traces. View server state allows them to view a whole lot of server dynamic management views and objects and X events without actually viewing any data. And so again, you should know your regulatory environment, but it should be perfectly safe to grant view server state and view database state, which allows for database level DMVs without having developers access any sensitive data. And then view any definition allows for viewing the definition of objects, the code in a stored procedure, the definition of a table, again, without granting them permission to view data. This may be appropriate to give even to a developer in production. And then to grant these permissions, again, you grant the permission to the principal. And of course, what I've done wrong here already, again, just to remind you, is that I granted it to an individual. Instead, I should be granting to a security group. So these permissions are given by the grant syntax. I could follow this up with a revoke syntax to revoke the grant. So let's go through a simple scenario of the DBA working with a developer named A Gump to troubleshoot a database that stores ping pong scores. So there's a trouble ticket and the developer comes to you and says, hey, I hear there's some bad results in the ping pong score table. Go ahead and grant me permissions to that. So I, assuming there's no regulatory impediments here, there's no sensitive data in the table, as a DBA, I can grant select on the table game.pingpongscore to the developer's individual AD account. Again, ideally, I'd be doing this to a security group instead, but bear with me, this is a simple exercise. So the developer has located the bad data. Now we grant execute on a stored procedure because the developer asks to insert some data into the database via the stored procedure, which should be recording the ping pong scores, and they want to insert some sample data. So then there's multiple stored procedures involved with operating this database, and they need to be able to execute all the permissions, all of the stored procedures. So I can actually grant execute in the current database context of the ping pong scores database to the developer account. Notice there's no on here. I am granting execute in the current database context, so I can grant execute to all stored procedures that have been developed in this database now and forever. This seems a little risky, but don't worry, I'm going to revoke it at the end. Then the developer has located a problem with one of the stored procedures. They need to be able to verify the code that's been deployed, figure out maybe what went wrong, compare it to what's in source control. So I grant view definition on a single stored procedure to the developer, and now the developer can compare the script to what they have in source control, for example. Then the developer wants to do an extended event session to figure out what else is going on in the application, so I grant alter any event session so that they can do an extended event session. And then maybe they want to look at some DMVs about indexing or sessions or wait stats, all very valuable performance data that doesn't give them access to actually view any data. I can grant them that. And then, of course, because this is in production and I'm a responsible DBA, I would have scripted all of this out, and then I can just change all the grants to revokes, and then I can revoke to remove all these excess temporary permissions from the developer's account. One more detail, I have been granting these permissions to the developer Gump's admin account. The A underscore is an admin account. Different enterprises use different naming conventions for their admin accounts versus their individual day-to-day accounts. So let's talk about this. It doesn't really matter to me what naming convention you use, of course, but what does matter is that most IT staff have two accounts. One for day-to-day access, one for admin access. Let's talk about that some more. So this is a security presentation. So we have to talk about how we as DBAs handle our own credentials and access to SQL data. This isn't uncommon. Many of my clients in my consulting past, and many of you, already have this type of setup in place. But many are lax about admin permissions for day-to-day accounts or the overuse of admin accounts for ownership and services and things like that. So here's some rules we need to stick to as professionals. Everyone should have two accounts in your corporate enterprise Active Directory, and we got to keep them separated. All administrators, including DBAs, should have these two. One for day-to-day access. This is what you log into your workstation with, your laptop or your desktop. This is what you use for email, Teams, intranet access, all that stuff. And then you have one credential that doesn't have any of those permissions for production admin level access only. The day-to-day accounts may have some production read-only access to things like non-sensitive databases, including like metadata, job status and history, error logs, SSI, SDB logs, logging databases. That's okay. But if you actually want to change anything, you have to use your admin account. And so you're remoting in using a jump box, preferably not using a run as, but I could see cases for that. Now, the same domain accounts that have production access to the SQL servers, to SQL data, should also not be the same accounts that have VPN or remote access. This is really important so that no one single credential could be used by folks across the world to get into your SQL servers. There has to be two credentials, one for production data access, one for VPN, and one for day-to-day, so maybe a total of three. but I understand using that day-to-day one for VPN. So let's talk more about some common permissions for non-sysadmins. So these would be for people's day-to-day accounts, right? Or their admin accounts if they're not supposed to have access to data. Show plan, this is for viewing execution plans for executable queries. This could still be useful to developers to be able to see what the execution plan is for a query without actually being able to execute the query. Impersonate, we're going to talk more about this. This allows for testing rights with execute as. And execute as is often used by sysadmins to test what permissions have actually been given to someone else who's not a sysadmin. Connect all databases. This allows a login to set any database context, but grants no other rights in each database. This is potentially appropriate for day-to-day accounts for some things because it doesn't grant any other permissions. You should really know what you're doing, though, especially with this one. Select all user selectables. This grants select from all objects in all databases. So this is potentially appropriate for day-to-day accounts, but not if you have sensitive data, not if you have anything that's PII or classified data. Be aware of your regulatory restrictions. And while select all user securables does sound handy, especially for reporting, it's probably overreach. So let's talk about control permissions. So we talked about the sysadmin server role, which is the everything permission. And we talked about the DB owner role in each database, which is the everything permission in each database. These are commonly granted to admins. Some other permissions you might find useful are the control permissions. These are most useful if you're trying to craft a permission set for an admin that's just short of admin. For example, something that has access to maintain a server, but maybe not certain key activities or databases or tables in those databases. The one big difference between sysadmin or DB owner and the control permissions are that control permissions can be affected by deny. Sysadmin and DB owner roles are not affected by deny. So let's demonstrate this. And we're going to demonstrate execute as well. So here let's demonstrate how control permissions can be denied, and also the execute as permission I mentioned earlier. So I can set my context. I can create a login for a domain user. Again, I should be using a security group. This is in SQL Server, so it's from Windows, from my local Active Directory. I'm going to grant control server, which is effectively the same as sysadmin, but remember it can be subject to deny. Then I'm going to deny view server state. There's no real good reason for this, but just for the purposes of this explanation right here, this would deny the ability to access certain dynamic management objects to the username. And then to test out, I'm going to go and execute as the username I've been granting permissions to, and then I'm going to do a select from a DMO. And this DM exec cached plans is one of those dynamic management objects that is granted by view server state, or in this case, denied by view server state, and this statement will fail. I will get a permission denied error. So I always put a go here, and I'll explain why, and then I revert. A revert always should follow an execute as. The revert changes me back to me. I'm no longer impersonating dom/username. And that last revert is key here. You need to be careful because in case of an error, like the error we just intentionally created, without that last go before the revert would not have executed. I always put a go before the revert to assure that my execute as is reverted. Even in the case of an error, a non-fatal connection error, of course. Of course, our test fails. We expected the select statement to fail, so we wanted that revert to fire, thus we need the go. The revert only affects one execute as. And if you execute as multiple times, it could have multiple reverts that are needed to undo them all. So always, always, always script out your revert and put the go in front. Execute as makes it possible for you to simulate the permissions of another principal. Always follow the execute as a revert, which stops the impersonation. A revert only affects member one execute as. And if you ever get kind of tangled up and you're confused about what your session is currently impersonating, you can always do this. Select original login, which is the name of the user at the time of connection. So that will never change. Even if you do an execute as user or execute as login, that original login, that's you. And then current user is the name of the user you have currently assumed. When these two match, you're not under the effect of any execute as. So this can be your reality check, your spinning top in the end of the movie Inception, to make sure you know who you currently are. And if you're not who you expect to be, do one more revert to make sure that all your execute as commands, which can become nested, are reverted. All right, so we've covered authentication and permissions. Let's talk about some more advanced security topics, ones that everyone needs to be aware of. Let's start with SQL Injection. So this is a webcomic from XKCD I've seen tacked to a lot of cubicles and a lot of DBAs. Talking about little Bobby tables and the SQL injection attack that someone made by naming their son with a semicolon and a couple dashes at the very end. Similarly, this is also a SQL injection attack, trying to insert user enterable data into a field that is not sanitized. So, what is SQL injection? It's trying to pass in a command to the database that's not expected via text entry field, essentially. So SQL Server is better than some others, but is not immune to SQL injection attacks made possible by security ignorant development. This is a much larger topic with lots of info out there. I won't do it justice today in just a few minutes, but I will talk about what we as data professionals can do to combat SQL injection. Developers are the ones responsible for preventing or allowing vulnerabilities. So they must be aware of SQL injection blocking patterns on public websites, like parameterizing the input from a website, use stored procedures, sanitize the input of special characters, scrub them out for semicolons and dashes if they're not expected to be there in the text field, for example, single quotes and double quotes as well. And then don't run website logins with more database permissions than are needed. Again, use stored procedures. And we'll talk later about why stored procedures are so important and useful in dealing with security. But real basically, if it's a search page or something like that, make sure it has read-only permissions. If it's something that's writing data to the database, make sure it only has permissions to write data to those specific tables, or preferably just to execute certain stored procedures and no other permissions. This is why we don't run websites with sysadmin or DB owner permissions. So what can we as data professionals do to prevent SQL injection, even when we didn't develop the code or own the applications writing to our database? We can refuse to give sysadmin or DB owner permissions, and we can demand more specific permissions from vendors, from applications, from developers. We can design tables with appropriate data types and lengths to make sure that if it's a number, it's a number. If it's a character, it has a certain limit. We can insist on stored procedures for public-facing operations. Be aware, too, of what databases have public-facing apps to them. We can insist on stored procedures for entity framework or any other ORM, object relational model. Any operation involving two or more entities, it's probably going to perform better in a stored procedure anyway. Ask the developer kindly to write a stored procedure instead of using the data layer there. What else can we do? We can avoid apps running with permissions like DB Data Reader or DB Data Writer. And certainly do not let apps run as DB owner. Again, DB Data Reader allows it to read from any table in the database. DB Data Writer allows it to write to any table in the database. This is likely not the case for some applications, especially if they have different users connecting to the application in different roles. Avoid the use of execute as, that thing we demonstrated earlier, in code, which could allow injected code to execute with elevated security in certain objects. In fact, I would never recommend using execute as in code unless you really know what you're doing. Train developers on patterns of stored procedure parameter sanitizing. Never use dynamic SQL commands like exec or sp execute SQL with user enterable data from a website, a form, or a search bar or something like that. Provide links, attention, and visibility to project managers and developers for SQL injection awareness. That's strategic. Let's talk about some more strategic things you could do. You could lobby for pen testing or SQL injection detection tasks in sprints. There's lots of white hat injection testing tools out there. With Azure SQL Database, you can enable this thing with a couple quick clicks called Azure Threat Detection. This is a security intelligence feature built into the Azure SQL Database platform, activated with a button click. It uses machine learning to alert you to suspicious activity like irregular usage times or IP addresses or suspected brute force or suspected SQL injection attacks, and a lot more. So what other easy steps can you use to secure your database? So Management Studio has this thing called the Vulnerability Assessment Tool. It was introduced in 17.4 in SQL 2017. Many of its findings are good, common sense database level permissions issues that we're discussing today, like public, guest, user-defined roles, orphan roles, least privilege permissions, and a lot more. Okay, so we've talked about permissions. We've talked about some operational or strategic security topics. Let's talk more about database permissions and how some important database objects can help make your databases and applications more secure. Let's start with stored procedures. So, stored procedures require execute to run and do not require any underlying permissions like insert, select, delete, as long as you're obeying 3 rules. The first rule, the stored procedure doesn't perform identity insert on a table, which requires alter permissions that aren't abstracted. In fact, it can't do anything that has to do with alter. Identity insert happens to be one of those things. 2, all the underlying objects have to have the same ownership chain. It's a little more complicated. Just understand that usually all the databases you're creating do have the same ownership chain. Topic for another presentation. And 3, and this is the big one that a lot of people run into, do not use dynamic SQL commands like sp execute SQL or exec SQL. If you do that, this built-in SQL abstraction layer for the permissions of a stored procedure is automatically disabled. But otherwise, given those conditions, given you haven't broken any of those 3 rules, thanks to the database permission chain, you could, in theory, grant execute rights to stored procedures that do insert and update and delete and selects from all the tables, grant no other permissions to that table, and then the users can read and write data from that table using those stored procedures only. You could even go so far as to deny select to public, and then users would be prevented from accessing any objects from any application, including sideloaded applications like Management Studio, Access, or Excel, or the Office suite. User access to data is forced to go through stored procedures, forced to interact with the database on your terms. That's a good thing. Views operate in very much the same way. This is helpful. It's very similar to stored procedures. Select permission to query a view. You do not have to grant access to both the view and the table to get data out of that table. This is helpful. In this way, you can provide horizontal or vertically partitioned views of your data, excluding certain columns, for example, or rows. This is a way to essentially perform row-level security, although row-level security is a feature in SQL Server across all platforms, Azure SQL Database, Managed Instance, Azure Synapse Analytics, as well as SQL Server since SQL Server 2016. It allows you to apply a security policy to specific users, filtering certain tables. You can then block reads and writes against tables without the use of triggers. It would be a permissions block. For example, you may have legacy databases with a mixed security environment of legacy and modern applications, perhaps low-code applications and mobile applications as well, and you want to help developers enforce a single, consistent row-level policy at the database level. So row-level security, this feature, like many others, is very well documented, and there's lots of samples on docs.microsoft.com to help you implement this. Okay, back to database objects. The last one we'll talk about is user-defined functions. So similar to views, a user-defined function will allow a user to select data from tables the user doesn't have access to. Keep in mind that the performance impact, though, of functions can be severe, especially if you put a function in the select portion of a query. Overuse of user-defined functions are common causes for performance issues. And there's high potential for what essentially becomes a cursor-like effect, where if you have 1,000,000 rows in your row set, the function had to be called 1,000,000 times. Now, in newer versions of SQL Server, and the features have also been rolled out to Azure SQL Database, in 2017 and 2019 addressed bad performance for some of these issues. So in 2017, the performance feature called interleaved execution helped with the performance of table-valued functions. And in 2019, there's a new scalar function inlining feature, which helped reduce the negative impact of abused scalar user-defined functions. We're not going to talk any more about those, but go look into those if you suspect you might have performance issues in your database that could be resolved by newer versions of SQL Server out of the box. So now we're going to go to a quick demo to demonstrate how stored procedures, views, and functions abstract the permissions necessary to select underlying table data. And these queries that I'll be including are in the toolbox that are included with this presentation. So here I'm going to demonstrate in Azure Data Studio. I have two connections open. One, I'm connected here as a sysadmin to an Azure SQL database that I have running up in Azure. I'm going to go ahead and create a user called deny principal with a very simple password. You notice it actually does comply with the password policy because in Azure SQL database that can't be denied. And then over here I'm going to connect as this deny user in my second screen. And you see I am now connected as this deny principal. I'm going to go ahead and create a table here, and then I'm going to insert 3 rows into that table. And then I'm going to create a view on this table. The view does nothing more than just select from the table, and it's going to change the column name and an alias, right? So I'm going to create the view, and then I'm going to grant select on the view to the deny principal. Now over here, I'm going to see what I can do here. Can I select from the table itself? No. Select permission has been denied to the table. Can I still get access to that table via the view? Yes, I can. Now, if I deny select to the table, still can't get access to the table, I can still get access to the table via the view. Via the horizontal and potentially vertical partitions that I've created via the view, I'm denied select access to the table. I can still query the table via the view, but I'm doing it the way that the developer wanted it to happen. Similarly, a stored procedure could be created. I'm going to go ahead and create a stored procedure. It does nothing more than select from the table, and I've granted execute to the table. I cannot select from the table. I can still get my data out via the stored procedure. This stored procedure did not break any of the 3 rules that we talked about stored procedures needing to follow. Let me go ahead and deny select to the principal on the entire database. Well, now I can't use the view or the table. I could only use stored procedures. Maybe that's great to me as a DBA, but let's not do that. Maybe let's not cut out views as well. So I'm going to revoke the current select on the entire database, and now I've got my data out via the view again. Still can't access it via the table. Okay, let's break one of those 3 rules that we talked about with stored procedures. So I'm going to do the same thing. I'm going to create the stored procedure with an SP execute SQL statement. This is bad, right? Now, I'm not exactly intaking any user interval data here. This is completely unnecessary, but I do want to demonstrate why this is going to break that abstraction. So when I go to execute in my second connection here, the ad hoc stored procedure, I have execute permission, but the stored procedure was no longer automatically allowing me to access the underlying table. So I would have to have select permissions against the table for that to happen. This, by SQL Server, is an automatic built-in feature. And the lesson here is don't use SP execute SQL and rely on that as part of your security model. Finally, let's demonstrate this in a table valued function. I'm going to do the very same type of query here, just selecting from the table, and then I grant select on the function to the principal. Over here, I still cannot access the data in the table, but via the function, I got my data out. Impress your friends at parties, show off to your parents, show your significant other. This is really cool party trick. Demonstrate just how database objects can extract those permissions necessary from the underlying table. Okay, in the last few minutes I have available, I want to talk about special and service accounts here. So first I'm going to talk about what is DBO. We mentioned this at the very beginning. Since 2005, that DBO part has changed. That second part is now just the schema. The schema is just a securables bucket inside of a database that you can use. So what is a schema? It's just a securables container. Schemas contain other database objects, tables, views, stored procedures, anything like that. And most importantly, that schema no longer implies ownership. By default, objects inside the default DBO schema, that's where they're created. Additional user schemas can be created. Permissions can then be granted to schemas as a set. For example, some logical schemas that I use in data warehousing. I might have a staging schema, an ODS schema for views as I transform the data, an audit schema for system metadata about how the ETL is running, and then a warehouse schema for actual facts and dimension tables. And you could imagine that the permissions on each of those schemas would be much different. You could also divide it along business lines. So inside the same database, you could have sales, HR, accounting, reporting data, and you could grant permissions to each one of those schemas differently. So back to what is DBO. I haven't really answered what DBO is. DBO was this special user inside each database that had sysadmin permissions, which by default owned any object created by an admin. In SQL 2005 and above, DBO is still a special user that sysadmin logins are mapped to inside each database. We actually saw that earlier in that earlier screenshot. So what is ownership? Microsoft has mostly done away with the terminology of users or logins owning objects, such as databases or schemas. Changing the authorization is now a more accurate term to describe ownership of an object. For example, the old SP change DB owner is deprecated, replaced by alter authorization on database. This syntax is for changing the quote owner unquote of a database, which hasn't been updated in the Management Studio UI. The UI still says owner, but in the syntax it's been renamed to authorization. Databases should be owned by service accounts, not by interactive accounts. Let's talk about that. Interactive versus service accounts. Interactive, again, means used by a human, typed in, and therefore potentially locked out or expired. Individual day-to-day accounts and admin accounts are interactive accounts. These are common accounts, as in an entire vendor has access to an account called the vendor's name, or an entire team shares a SQL login or a Windows authenticated login. Not recommended that common accounts are set up like that. Everyone should have an account with their name on it and then a member of a role. It's best to grant permissions to interactive accounts via groups and roles. Again, never directly to the person. Service accounts are never typed in by a human. So regular AD accounts where the password is long and, more importantly, not known to anyone outside of a password vault. There's also this concept of MSAs, group MSAs, and VSAs. We'll talk about that in a little bit, but those are all under the same bucket of service accounts. This is a chart. Again, note here that none of these system objects or accounts are appropriate to be owned by an interactive account. Something with your name on it should not be the owner of a database, an agent job, a schema, the availability group, which actually has an owner. It's not in the UI. The SQL service account, application connection strings, none of these should ever be interactive accounts. And by the way, a service account becomes an interactive account if a bunch of developers learn the password and start using it to log in instead of using their own permissions. That's a problem. You as a DBA need to fight that. If your interactive account expires while you're on vacation, or is locked out maliciously or accidentally, or disabled when you leave, stuff is going to stop working if it owns any of these things. It's going to stop working in fun and exciting ways for your successors. You should regularly check to make sure, for example, that you have not accidentally become the owner of a database or a job that you create. Including jobs created by Management Studio's built-in maintenance plans, you very often become the owner of the jobs that are created by those. Keep an eye out for that and go fix those, change it back to a non-interactive service account. Now, one question you probably have is if the built-in SA account, the SQL authenticated login that you probably set a password for at install, does that SA account count as an interactive account or as a service account? The answer is, it depends on how you use it. I'm okay with databases or jobs being owned by SA as long as nobody is interactively using the SA account. Ideally, nobody uses the SA account. Again, everyone's supposed to gain access to the database through Windows admin credentials linked to their person, to their admin account specifically. All administrators, even contractors, managed service providers, vendors, should be accessing your SQL Server via their personal Active Directory admin level accounts. If the SA password is painful to enter and not passed around and only stored in a password vault somewhere and not known to developers, I'm okay with calling SA a service account and using it as such. But if you have old school administrators who like to log in as SA, then no, we need to fix that behavior because it's problematic for all the reasons we've already discussed. So let's talk about VSAs versus MSAs, or virtual service accounts versus managed service accounts, and then group managed service accounts. So VSAs are specific to a machine. For standalone SQL Server instances, they're perfectly fine and secure to use as the SQL Server or SQL Agent service accounts, for example. They're installed that way by default. Unless you specify another service account, SQL is going to install itself with a VSA. And they're managed by the operating system to simplify the service's security. It's automatically managed and can even be given access to resources outside of the network. Whenever you do that, like via a Windows file share, for example, you append a $sign to the end of the account because it's used there as a local computer account. However, if you're configuring an old-fashioned failover cluster instance or an availability group, it's best to configure the SQL Server service account to be a service account managed by the domain controller. This can be a standard account you create in AD with a strong password that nobody knows, and you only enter it once. Or you can use a managed service account. In fact, Microsoft recommends using a managed service account with minimal privileges for any time a SQL Server needs to reach outside its own operating system. Here's the great thing about MSAs. They can't be used interactively. And when you go to provide an MSA to the SQL Server Configuration Manager, for example, you just leave the password blank. And MSAs can only be used on servers they've been configured for, often with PowerShell. For example, once the MSA has been created in Active Directory, this PowerShell here is all that's needed before using an MSA as the service account for SQL Server. It's really that easy. Now, if you want to configure the same managed service account across multiple instances of SQL Server, like in a failover cluster or in an availability group, for example, you want to use a group managed service account, which can be installed and used on multiple servers. Active Directory will automatically and regularly update the GMSA password on each server, quietly and behind the scenes without any interruptions or outages or restart. Note that a lot of what I'm talking about is new in the last few years on this page may not be available on older operating systems or older SQL Server versions. For example, support for group MSAs was introduced in SQL 2014 and Windows Server 2012 R2. And SQL 2016 is needed for some other scenarios with group MSAs. Okay. If you're interested in security or attending past Summit to help your company better handle security or develop more secure applications, just a reminder that this session is one of a 4-part learning pathway on security. Over the next 3 days, John Morehouse is presenting Part 2, Understanding Modern Data Encryption Offerings for SQL Server. Jeff Renz is presenting on Securing Your Data in Azure, Tips and Tricks. And Ed Layton Dick will cap it off with a presentation on Building a Security Dashboard for SQL Server. Thank you very much for attending. Here's a page I always put in my presentations with links to anything that you'd like to continue reading and learning about. Thank you very much for attending. Please enjoy the rest of the next 3 days and have a great week.